I said functions, I mean equations. All right, so we're looking at solving trigonometric equations. First one we're looking at is 3 sine x minus 2 equal to 5 sine x minus 1. All right, so we want to solve this the same way we would any other equation. You can combine your like terms. You get all of your terms with x on one side, all of your terms without x to the other. So really, this is algebra. Subtracting 5 sine x from both sides. So it's negative 2 sine x minus 2 equal to negative 1. Then you add 2 to both sides. Negative 2 sine x equal to 1. And divide by negative 2. All right, so questions so far as what we have done. All right, so of course we're not done. We want to figure out what x is, what value or values for x will fit into this application of sine. In other words, when I take the sine of this value, I get negative 1/2. So you could lean on the unit circle, especially if you don't have them committed to memory. It's talking about when is sine, like I said, equal to negative 1/2. That's what we should be asking. So let's see, do I have my unit circle up? There you go. You guys should be able to see it. Yeah. So when we look at where, remember sine is my y coordinate. If you look at where negative 1/2 exists as the y coordinate, that's at 7 pi over 6 and 11 pi over 6. All right. So those are our two answers. And don't forget what actually happens here if you're talking about actually solving for x. Remember what we're doing is we're applying sine inverse to both sides to get rid of the sine that's applied to x. So we're actually looking at it like sine inverse. And some of you may have calculators that can actually do that and give you the exact value. So it just depends on your calculator, the type of calculator that you have. If not, then you can do what I just did, which was go to your unit circle. All right, so like I said, that was 7 pi over 6 and also 11 pi over 6. Now, it's funny that your classmate mentioned periods. So you do have to consider that if there are no stipulations on the actual equation or the solving, you'll see what I mean. Let's see, now the next question. Yep, might be the next question. When you have stipulations that say, okay, your answer cannot go past 2 pi. So since this one does not have that, then what we would do is add the period to it, which is 2 n pi. And then here add 2 n pi. So for every revolution or every rotation, that answer would be true. In other words, if you were to add 360 or 2 pi to this, then that will still be sine. Sine will still give you -1/2. Or if you were to add 720, which is 2 pi times 2 or 360 times 2, you would still get the -1/2 when you apply sine to it. So you have to give an account for the period. It's not period intervals. Don't say period intervals. I'll just say period intervals. No, it's not intervals. Anyway, I'll just say periods because the word I'm looking for, I can't think of the word. I'll just say periods right now. All right. Questions before we do another one? That's the foundation of what this section is.
No questions.
All right. Sounds good. Here we're looking at tan 3x equal to 1. All right, there's something in the chat. Can you go up a second? My computer just spazzed out. Okay. All right. You just, I don't know where you want me to go. This is where we started. So you can let me know. All right, go down slowly. All right. Okay. All right. All right, so here we have tan 3x equal to 1. All right, so notice the difference between this and the last one. When we got to a certain point, sine was only being applied to x. Here we have tan being applied to 3x. So we're gonna have to consider something else or continue to solve after, we get rid of tan. All right, so we got tan inverse. Power 4 is gonna be 1, yep. So of course these cancel. So that'll be 3x equal to power 4, because power 2, power square root 2 be negative. Negative should be power 4, and I think I'm looking at, oops, wrong button. Negative, power 4. Nope. Okay, no, that's good enough. All right. So we have, when we apply tan inverse to both sides to get rid of the tan on the left, then we apply tan inverse to 1. That will be power 4. but that actually happens in two places. And so you're talking about, I'm just going to show you my rationale. When you have it's in the first quadrant and in the third quadrant. And you're talking about pi over 4 and 5 pi over 4. Let me make sure my unit circle, 5 pi over 4. So you're going to have sine over cosine, which is your tangent. So you're just talking about square root of 2 over 2, square root of 2 over 2, and that'll give you 1. And then negative square root of 2 over 2, negative square root of 2 over 2 will also give you a positive 1. So that's what I'm talking about. It happens in two different places. All right. All right. So when I write this up, though, let's go ahead and solve, and I'll see what show you what we can do to consider this 5 pi over 4. So I want to multiply both sides by 1/3. So that cancels out this 3, leaving me with x. And this is pi over 12. Now what we can do, and we're talking about our unit circle. Pi over 4 is over here. 5 pi over 4 is over here. And what we can do is actually do a period of pi. And so I probably should have did that over here. Okay. Let's write my pi over here in pi and multiply that whole thing by 1/3. All right. So why I did that is because I want to write this answer as simple as possible. And as far as the book is concerned, they want you to write it this way as well. So instead of giving you both pi over 4 and 5 pi over 4, they would rather you write it this way. And so you write the pi over 4, and then you would go just half of a rotation, which is pi. A full rotation is 2 pi. Half a rotation is just pi, which is right there. So if I multiply both terms by 1/3, that will be n pi over 3. I had to write that in black. So 1/3 times pi over 4 is 12. 1/3 times the n pi is n pi over 3. All right. Questions on what I did there? Solid equation, multiple angle. And that's it for that one. Questions on that before we go to try another one?
Not yet.
All right. Make sure I'm not leaving off anything before I go to the next one. I think we're good. Because they asked for this. All right, so let's go to directions. I don't know why I wrote solve all of them. I'm saying solve. So let's go to cosine squared x plus. Oh, before we go here, I just saw something. They wanted us to, because of this, remember the last one didn't have that. So we just had to give a general answer, which were these two. But because of this, we have to give all the answers that fit, that plug into here. So I have to go through and plug in 1, 2, 3 up until we get to a point wherein it goes past 2 pi. So let's go ahead and do that real quick, because I was looking at the next one, then I looked up and saw how they gave multiple answers instead of the general answer. So let's write this note. All right, so because of that interval of 0 to 2 pi, the answers desired should be specific, not a general solution involving n. All right, so let's do it. We start off with n being equal to 1. I started off with 1. I should have started off with 0. Anyway, it's there. So it's 4, it's 8. All right, so that's 5 pi over 12, 12 pi over 12. I said 12 power 12. Power over 12. 9 power over 12. Yeah. And also we can already look ahead as to what numbers we're looking for. Remember 2 pi is the marker. Where can I write it? 2 pi is the same thing as 24 pi over 12. So once that top number goes past 24, then it's not a valid solution for this interval. So that's n equal to 3. We did 1, 0, 2, 3. I think it's only like a few more. All right, 5. And that can reduce down to 7 over 4. And I think that was the last one. I think 6 is going to take us higher. Excuse me. So that 25 pi over 12 would be greater than 2 pi. But that would just be valid if your calculator is capable to plug in the numbers. Yeah, if you have the capability calculator or something of that nature that can find those 6 values, talking about n being 0 to 5, that's fine. But everyone, may not have that type of calculator in front of them. So if you had to do it by hand, this is the way you would do it. And like I said, what would stop you from going any further is recognizing once you plug in a value, you went over 2 pi. And remember, our interval went from 0 to 2 pi. So we had to consider all of those values. So yeah, it's a different book, so I didn't see that one. Last time I taught out of a different book, so it's all good though. All right, questions on what we did there. So I believe there are things out there that you can use to help you find those 6 solutions without the work. But if not, then you have to, do a little grind on that with that fraction work. All right. Cosine. Now let's look at the cosine squared x plus cosine x minus 1. And they give us that interval as well. So we can actually factor this. So we can factor it out as 2 cosine x minus 1 times cosine x plus 1. Set each piece equal to 0. Here add 1 to both sides. Divide by 2, we have cosine is equal to 1/2. Here we'll subtract 1 from both sides. Cosine is equal to -1. All right, cosine, well, we're looking at this now. So if you want to know when is cosine equal to 1/2, when is cosine equal to -1? So here I know we're talking about pi. And cosine being positive 1/2. I can pull out my unit circle just to make sure I get the other piece. I know it's 2 of them. So we're looking at pi over 3 and 5 pi over 3. And once again, we can get this right. All right. So once again, going back to our unit circle, you're talking about cosine, which is your x coordinate. You want to know when is it 1/2? That's right over here, pi over 3. I didn't know I could draw on this. Okay, that's cool. All right, so right here, pi over 3, and then 5 pi over 3. Can you guys see my drawing on the mark on the unit circle?
Yes.
Okay, cool. That's cool. You know that. But yes, questions on that cosine half, and then you said we had cosine of -1. So when is your x coordinate -1? That's over here at pi.
So the only question I had, how well do you believe the book does in explaining this? So I'll actually probably need that after class. And when I go ahead and do the homework, I'll need to refer back to something. How well do you think the book portrays this in your mind?
Um, it does fairly well. Now it doesn't go connecting. So the different things that I say and the different things that I do every single move. Now, I'm not sure if I've ever seen a math book that's going to do every single move. So all of your algebraic moves, um, that I've done, they're not going to give you all of those steps because they assume that you know how to do that through algebra. Reverting back to your unit circle, they may not do it like that because I'm looking at the book. It doesn't necessarily say anything about saying look at your unit circle as a hint or anything like that. But they expect that at this point, cosine 1/2 will give you, pi over 3. So certain things they are going to expect you to know. Um,
Okay, I've got no problem with that.
yeah.
And I've got no problem with you actually going back and redoing some of that stuff as a refresher as well. So
Okay. Okay. So, yeah, so like I said, this is not a bad book. I've seen a lot worse, but yeah, this one is fine. Um, yeah, and then I'm always here too. If you have any questions, I can always shoot your email back, or like I said, or another Zoom if individual Zoom session if we need it. So,
that's great to know. Thank you.
no problem. All right. Questions before we do another one. So once again, this one was less involved considering the last one, because it was just cosine. And remember, we didn't have that extra piece on the inside of the application, which was right here, that made us do the extra, stuff like this. It was just straightforward cosine x equal to 1/2 and cosine x equal to -1. So let's look at another one. Try to run across as many scenarios that you guys may see. So we have 4 sine squared x minus 1 equal to 0. All right, so we can solve for sine. Adding 1 to both sides. Divided by 4. Then take the square root of both sides. And don't forget the square root property, plus or minus square root of 1/4. So that means sine x is equal to positive 1/2, and sine x is equal to negative 1/2. So make sure we are okay before I go any further. So negative. So each one of them should have 2 answers that fit this solution. And I'll go back in a second, but notice we want to know when sine is negative 1/2 and positive 1/2. So sine is positive 1/2 right here, and positive 1/2 right here. So we're looking at power 6, 5 power 6, and negative 1/2 right here, negative 1/2 right here, which would be 7 power 6 and 11 power 6. So those are your 4 answers. That's okay. All right, so we have tan x sine squared x equal to 3 tan x. Oh, same thing of 0 x 2 pi. So set both sides, when I set both sides, set one side equal to 0. So we can subtract tan x from both sides, or 3 tan x. Then we have tan, that's in both terms. So we can actually factor tan out. So we just factor the tan to the front. And now, let's look like we can set each piece equal to 0. So on this one, we'll add 3 to both sides. Then we'll take the square root of both sides. So x is going to be sine inverse. Do you want to do both of them? I'll just leave it like this right now, just cause. All right, questions before we finish it off.
Could you go up a little bit?
So that's the beginning of that problem. Oh, where's my calculator? All right. So here, tan inverse of 0. So the solution here would be when sine is 0. So that should be what, 0 and pi. Make sure I'm good. Yep. So those two are 0 and pi. And then here, this is 1.73. So that's out of the domain. Remember, the domain goes from -1 to 1. Yep, -1 to 1. So no solution for this over here. And then if you were to do sine inverse of the square root 3, it should give you undefined or something, some error message, that your calculator will produce. All right, those are only two solutions, 0 and pi. So let's do another one. All right, got 2 cosine squared x plus 3 sine x equal to 0. One way we can look to deal with this problem is by changing cosine to sine. So we can use our Pythagorean identity here. Some things you may not see till you start working on it. Just like the last one, we didn't turn all the tan to sine or anything like that because we saw if you would have looked ahead, you could have saw that you could factor out or separate them like we did here. But in this one, that's not really an option. So turning cosine squared to sine would have been the easiest option. Then that can set us up for a quadratic scenario. So distribute, that's 2 minus 2 sine squared x plus 3 sine x. And probably rearrange these terms just like I would quadratic. Then, because I have this negative, and these are just algebraic, things you would do. If you have a negative on your leading coefficient, you'll multiply the whole thing by -1 or factor out a -1 so you don't have to have that negative sitting on your leading coefficient. And really, you're multiplying both sides by a negative and just multiply 1. So it's 2 sine squared x minus 3 sine x minus 2 equal to 0. Now factor. So it's -2, -1. Should be +1. So we have 2 sine x plus 1 sine x minus 2. Set each equal to 0. Subtract 1. Divide by 2. Here I will add 2. All right, so for that second one, sine x equal to 2. That 2 is outside of the domain. Then the next one, we want to know sine inverse of negative 1/2. And that should be 7 pi over 6, 11 pi over 6. Okay, so let's do at least one more and then call it quits. Unless you guys want a few more, you know. It's always aim to please. But try to give you enough scenarios so that you'll be able to reference as far as solution options. All right, so here we have sine x minus cosine x equal to 1. So in its current state, there's not much you can do with it. What we can do is square both sides. So we can square both sides with the anticipation of using sine squared plus cosine squared equal to 1, Pythagorean identity. So we'll see if it works. If not, go back to the drawing board. All right, so we'll expand that. Remember, that's going to be sine x minus cosine x times sine x minus cosine x equal to 1. Sine times sine is sine squared minus sine cosine minus sine cosine plus cosine squared equal to 1. So I would now combine my like terms and bring these two together. All right, so we got sine squared plus cosine squared minus 2 sine cosine. And cosine squared plus sine squared is equal to 1. So that helps us out a lot. Because now I can subtract 1 from both sides. And it actually cancels out on both sides. So we're looking at negative 2 sine x cosine x equal to 0. Now we can divide by negative 2. sine x cosine x equal to 0. And set each piece equal to 0. So that'd be 0 pi. So those be our our 4 values. 0 pi, and then pi over 2, and 3 pi over 2. So now before we do one more thing with this, let's stick with this problem, but questions on what we've done up to this point. So one note that we have to consider. All right, so whenever you raise both sides of an equation to an even power, you must check for extraneous solutions. So in other words, those are just solutions that do not work for you. All right. See, it was sine x minus cosine equal 1. So I'm gonna put these right here so I don't have to flip back. All right, so let's plug them in. First one, x being equal to 0. And if you have a calculator, of course, should be able to just plug it in the calculator. Yeah, that's 0, 0. So the first one does not work for us. See if I can slide this one in here. So that one works. Minus 0. So that one works, and the other one probably will not. Yep, -1 minus 0, 1. All right, so as far as solutions go, we said pi over 2. So trying those out, we plug those in, and we see that only pi and pi over 2 works as solutions for us. The other two do not, so they're considered extraneous. All right, and once again, that check work, you could just throw that in the calculator, and that should give you that value or values that aren't correct. If you're just trying to do a check, put sine 0 minus cosine 0 in the calculator, and it'll come out 0. So you don't necessarily have to do it all by hand, but just showing you the inner ins and outs of doing so. So that's it for 6.5. Questions, concerns, comments, some stuff may not come up until you actually start it. So I understand that as well. All right. Anything before we close out today?
No, I'm good here.
All right. Sounds good. Sounds good. So as I mentioned, try the stuff out, see if you get stuck. I'm going to try to get that test review posted sometime today or early tomorrow, and we'll move from there. All right. So you guys have a good one. Be safe, and I will see you guys on next class.
Take care.
All right, you do the same. Yep. Thank you. No problem.